All right, today we're going to be talking about balancing equations. We're going to be going through slides 1 through 9. So, with balancing equations, what we're going to see is that with the law of conservation, what that tells us is that in a chemical or physical reaction, matter cannot be created or destroyed, but it can only be changed from one form to another. Therefore, according to the law of conservation of matter, the number of atoms on the reactant side must equal the number of atoms on the product side. So this is why we balance equations. So everything before the reaction are called reactants, and then everything after would be the products. How do you know a chemical reaction has occurred? Color change, precipitate produced in a solution, odor or gas produced, light or energy involved. Symbols used in chemical equations. The plus sign is used to separate two reactants or two products. The arrow is a yield, so it separates reactants from the products. Oh boy, that one looks bad. The double arrows, what we see there is a reversible reaction, so it can go back and forth. Apologize for why it came up like that. S stands for solid. L stands for liquid. G stands for gas. And AQ stands for dissolved in water, so stands for aqueous. And then looking at the arrows with a certain sign over it, so for the heat, heat must be added to the reaction. For PT, catalyst added, a catalyst speeds up a reaction but is not used in the reaction. Chemical equations, so the reactants would be on the left side while the product would be on the right side. This substance are always separated by an arrow, so this arrow here is going to separate the product and the reactant. All right. The numbers in front of the chemical formulas are the coefficients, so what happens is these coefficients will again multiply through. So again, 6 times 2 would be 12 hydrogens, 6 times 1 would be 6 oxygens. All right, so our subscript again tells us how many atoms are located in this molecule. The 6 the coefficient will multiply them. The arrows will again separate the substances, the molecules from each other. How many of the substances are so the number of coefficients seen here are going to indicate how many of the substances are present. So there is one C6H12O6. There are 6 oxygen or O2. There are 6 H2O or water, and there are 6 CO2 or carbon dioxide. Finding the number of atoms. So multiply the coefficient by the subscript to determine the number of atoms in a chemical equation. So how many atoms of carbon are on the product side of the equation? So the left side, that'd be 6. How many hydrogen are the reactant side of the equation? That would be 12. And then oxygen. So we have 6 here. We have 2 here, but 6 times 2, that'd be 12. So 12 plus 6, that'd be 18 in total. So 6, 12, and 18. Again, there's no coefficient here to multiply here. So that would be the case. Okay, but there is here to multiply this by 2. And then you do the same thing on the right side. So again, if we need to have 6 carbons in total, so 6 times 1 would be 6, we have it there. Hydrogen, we would have to do 6 times 2, we would have 12 hydrogen in total. And then oxygen, 6 times 2 is 12, 6 times 1 is 6. 6 plus 12 is equal to 18. Balancing equations, in order to balance this, we would need A2. So again, we have 1 sulfur here, 1 sulfur here, but we have 4 oxygen on the left, 3 oxygen on the right. So again, multiplying the 2 out here, that would be a total of 6 on the left. Adding a 2 here, that would be 6 on the right. For this equation, we would have to put a 3 coefficient on the sodium hydroxide and then 3 on the sodium chloride. So again, we would have 1 iron atom each, 3 chlorine atoms on the left after the coefficient here, 3 chlorine atoms on the right. We have 3 hydroxide atoms. We only have 1 here, so again, we'll multiply 3 here. We would have 3, and then with the sodium, we would have 3 each. Okay? And again, the next one, We have C2H6 plus O2. After the reaction would be CO2 plus H2O. So again, we would have to put a 2 in front of the coefficient here and make it 4 carbons. 4 in front of this molecule here to make it 4 carbons. So that's equal. We have 12 hydrogens on this side. Multiplying this by 6, we have 12 on this side. Adding a coefficient from its O2 here, that would make it 14. 4 times 2, that'd be 8. 6 times 1, that'd be 6. So 8 plus 6, 14. So that would be equaled out. Oops. And then for this equation here, we would put the 2 in front of this NH or this ammonium because we have 3 of them. We would put a 3 in front of this ammonium because there's 2 of them. So 6 and 6, that'd be okay there. With the 2 in front of here, we would have, this should be a lowercase l, because it should be aluminum phosphate. But again, we would have 2 aluminum here, balances with 2 aluminum here. There's a phosphate atom here, 2 across, 2 across here. So again, it would be equaled out. All right, let me see, what slide are we on? Okay, and we're going to stop right there. Well, we'll do one more slide. All right, diatomic structures. With diatomic structures, remember HON, FCl, Bri. These are all the diatomics that we see. So whenever these elements appear alone, not in a compound in a chemical reaction, they are written as a diatomic. So water, after the reaction, hydrogen plus oxygen. So H2O is equal to H2 plus O2. So again, this would work for any type of diatomic. All right, we are going to stop here. We will continue on in class.